Yeah, next one is what? Next one is the chi-square distribution. Okay, next one is the chi-square test. So chi-square test we use for what? We use for test for the single variance and test for the independence of attributes and test for the goodness of fit.
Goodness of it.
Very good. So we use for these three cases, we use a chi-square test. Okay. Now we'll see. First we are looking at the this one, independence of attributes. Okay. For the independence of attributes, what is the what is the procedure? H naught. For independence of attributes, what is the H naught? Yes.
The two attributes are independent.
Yeah, the attributes are independent. The attributes are independent. Next, what is the H1?
The attributes are dependent.
The attributes are not independent.
Yeah, the attributes are not independent or dependent. Okay. Yeah. Next, what is the level of significance? They did not mention anything in the question. Will be taken it as a 5%. And what is the degrees of freedom?
R minus 1 into
R
C minus
minus
Very
into
good.
C minus 1.
Okay, very good. And what is the test statistic chi-square?
summation I into summation J into OIJ minus EIJ whole square by EIJ.
Okay. Okay, follows chi-square R minus 1 into C minus 1. And next one, table value. So table value, it will be depending on what? It is depending on,
Degrees of freedom, level of significance, alternative hypothesis.
yes. And now, if the chi-square distribution is a positively skewed, symmetric distribution or a positively skewed distribution?
Positively skewed.
Positively
Really
skewed
skewed.
distribution. So after the table value, we draw a curve and then we give a conclusion. This is the procedure. You know that, right? Now, we'll check it. The question, check that. This is the question. Data on hair color and the eye color are given in the table. Okay. Calculate the chi-square value. Determine the association between the hair color and the eye color. Association means what here? Association means it is a dependency relation. Okay, so relation means what is that? If the attributes are dependent, there will be a relation, right? If they are independent, there will not be any association. Okay, you need to check that one. So between the hair color and eye color, is there any association or not? We need to check it. That means whether the attributes are independent or not, we need to check it. So how can you see here? This is the data. Okay, this is the data. So here we have a 3 rows and the 3 columns. So what can be the degrees of freedom?
4.
4. Very good. 3 minus R minus 1 into C minus 1. That is 3 minus 1 into 3 minus 1, which is equal to 4. Okay. Now, what is the null hypothesis in this question? Both the attributes are independent. Independent means what? There is no association. Is it right?
Yes, ma'am.
Yes, ma'am.
Yes. And what is the alternative? The attributes are not independent. Not independent means what? The attributes are having an association. There is a relation. Relation exists between these two. Is it clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Now, here the data has given in a matrix form. Is it right? This is a table, 2 by 2 table we have. This is called the contingency table. But the data we cannot enter like this into the R programming directly. First, you need to enter in a vector form, and that vector you need to convert it into the matrix. So how to do that? That we will check it. So first remember, take the column values. Column wise, you need to take the values. So what do you have to take? 15, 20, 25. 20, 20, 20. 5, 10, 15. Like that you need to take. Is it clear? Is it clear, everybody?
Yes, ma'am.
Yeah.
Yes,
Now
ma'am.
here I'm taking a data. Hmm. Yeah, this is the data we got it. Now here, what did I tell you? First, you need to enter the data in vector form and then convert that vector into the matrix. Okay, chi-square test we will do if the data is in matrix form, because if it is a contingency table, then only we are going for the calculation of the expectations, right? So first enter the data. X is equal to C. Open the bracket. So how to take the data? How to take the data?
Column
Column
wise.
wise or the row wise?
Column wise.
Yes, take the data column wise. So here we cannot, yeah. So just check it here, 15, 20, 25. Enter the values. Correct? Yeah, 15, 20, 25. Okay, first column is over. Next column is what? Next column is 20, 20, 20. Take that. 20, 20, 20. Okay. Next column is what? It is 25, 20,
5, 10,
50.
15.
25. What is the next value?
5, 10, 15.
Okay, 25,
5, 10, 50.
5, 10, 15, Amma. Ah, sorry, sorry.
Yes, ma'am.
5,
Yes,
5,
ma'am.
10, 15.
yeah, 5, 10, 15. Thank you, dear. 5, 10, 15. 5, comma, 10, comma. Okay, we got this. And now, after entering the data, this is the data we entered into the vector form. Now, we need to convert it into the matrix. Okay, how can I do? For this one, I'm taking a mx. Mx is matrix form of the variable x. Okay, so how can we write that? How can we convert? Write the function matrix. Okay, write the function matrix. Which one you want to convert that? Which vector you want to convert? X vector. So x vector you want to convert it into the matrix. Okay, so in the matrix, how many rows and how many columns we should have? Check it. Check the raw data. What do you have? How many rows and how many columns?
3 rows and 3 columns.
3 rows, 3
Yeah,
And
columns.
3
write that. Very good. So write that number of rows. N row. N row is equal to how many rows? 3. N row means what? Number of rows. Okay. And next write that N call. N call means number of columns. How many columns we have?
3.
3.
3 columns. Okay. Now you just run this one. Okay. I'm running this X first. And then see, I told you to clear this first. Clear the environment window first. And now run it. Run the X and run MX. Okay. Could not function. Oh, spelling mistake.
Matrix.
Matrix. Yes. Thank you. Now. Yes. Got it? Now check it. What is the MX then? Check it MX. Yeah, got it everybody. Now check the data. Do we get the matrix? Did we get the table? 2 by 2
Yes,
table?
ma'am.
So you just check
Yes,
it.
ma'am.
First it is taking the column and next second column and third column. Did we get the same table? You just check it in that 15, 20, 25,
Yes,
25,
ma'am.
25, 10, 15. Got the same table?
Yes, ma'am. Yes, ma'am.
Yes,
Yes, ma'am.
this is the way to convert. We converted, see, like this 2 by 2 table, we cannot enter directly in R. So what we are doing, first we are entering the data into the vector form and that vector we are converting into the matrix form. Is it clear? Any doubt in the conversion?
No,
No,
ma'am.
No,
ma'am.
ma'am.
No. Now after this, there is nothing there. Very simple. Now you need to do the chi-square test for the independence of attributes, right? So write that CHI chi square. That means SQ. Yeah, you can see this. Can you see this? Chi
Yes, ma'am.
test. Press that. Okay, chi dot test. And in this one, it is asking X, Y, null. These all the things we use for the different thing. Don't go for this all the things. Don't worry about it. And now here we just go for this chi-square test we use for this function. If you are taking this, this is we use for the what is the goodness of fit also. But here we are using only for the this one. What is that? Independence of attributes. So what is that? Take this mx. Mx means what is the matrix form you have, that is you need to test it. Okay, so then run this. Yes, got the p value. Everybody, this is a chi-square cal value. This
Yes,
is the
ma'am.
chi-square cal value. and this is the degrees of freedom, and this is a p-value. Did you understand? Got the degrees of freedom 4 only?
Yes, ma'am.
Yes, ma'am.
Yeah. So chi-square cal value is 3.64 and p-value is 0.4561. Now do it. Then how can I do this one? What do you have to do? Write the p-value is equal to, what is the p-value? 0.4561.
6-1.
Then run. Okay. And next, move to the condition if. Open the bracket and write that p-value is less than 0.05. Then what we are doing?
Reject H naught.
Print accept H,
Print,
reject H note.
yeah, print less than means you are comparing with the probability value. So what is that? Reject H naught.
H note.
Okay. And next after this, go for this value. What is that? Here, what is the next one? Print, else. Open the flower bracket, then enter, print. What is it? Open the bracket and accept H naught. Okay, this is a condition already, you know that already I was explaining from yesterday. For each test we are writing this condition, if else condition. Okay, and then run this. So what is that? Accept H naught. Is it clear?
Yes, ma'am.
Yes,
Any
ma'am.
doubt anywhere?
No doubts, ma'am.
No, ma'am.
Yeah. So this is the way. First here, what is the point you need to remember in independence of attributes? Whatever the data has given to you. First enter the data in column, what is that, in a vector form. And then convert that data into the matrix form. And then apply the chi-square test. Is it clear?
Yes, ma'am.
Yes. And now move to the next one. What is the next test? What is the next test? Chi-square test for the single variance. Okay, we'll see the chi-square test for the single variance. What it is, we'll check it. Now, oh goodness of it. No, okay, let me finish this goodness of it later. Let me finish this one. Now check it. What is the question you have? Everybody read the question. Read the question. What is the data has given? Please let me know, dear. What is the data they gave? This data belongs to what? Am I audible?
Chi-square test for
Yes,
single
ma'am.
variance.
How can you understand this is a chi-square test for single variance? How can you understand? Okay, I have written here. You are telling, right?
No, ma'am. Because it is sample
Only
size is small and it is mentioned that it is variance.
Yes, very good. So in this question, here they have given you the data. This is the data I have given to you. And here, how many observations are there? 1, 2, 3, 4, 5, 6, 7, 8,
10.
9, 10 observations. 10 means it is a less than 30. Less than 30 means small sample. And they are concentrating on what? They are asking you to test whether the variance is 33,000. They are asking you to test whether the variance is 33,000. That means they are asking you to test the variance, means we need to use a chi-square test. Okay. If they are asking for the mean, then we use a t-test. If they are asking for the variance, we use a chi-square test. Okay. And here they have given you the raw data, and let me know what is the procedure first. 1 minute. Yeah. So now write that single variance, chi-square test for single variance. Now tell me the procedure H naught. What will write H naught?
Sigma square equal to sigma naught square.
Sigma square is equal to sigma naught square. Okay, fine. Next.
Sigma square not equal to sigma naught square.
It can be the not equal to or lesser or a greater. Based on the data, we need to take that. So in this question, what is the question now? You just tell me. What is the H naught and what is the H1?
Not equal to sigma naught square.
Yes, sigma square naught. Here, what is the sigma naught?
33,000.
33,000.
33,000.
33,000. Okay, 1 minute. 33,000. Fine. Right? 1 second. Yeah. So what is the H naught in the data? Sigma square is equal to 33,000. What is the H1 then in this question?
Not
Not
equal to
not
33,000.
33,000. Okay, very good. And what is the level of significance?
5%.
5%.
Okay, what is the degrees
5%.
of freedom?
N-1.
Yes,
9,
n
9.
minus 1. Very good. Okay, and here there are 10 observations. 10 minus 1, 9. Very good. And what is the chi-square cal formula?
ns square by
SN
sigma square.
square, NS square by sigma square.
Very good. And what is the small s square formula?
1 by n summation
1
xi
by n
minus x bar
summation
whole
I
square.
xi minus x bar whole square.
Very good. And after this, you need to go for the table value. Table value depends on the level of significance, degrees of freedom, this degrees of freedom, and the alternative hypothesis. Okay. And next, we'll go for the conclusion. I hope everybody understood the procedure, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Now, okay, you just move to the R programming. First, see the data. Okay, here we have a raw data, right? They did not give you the small s square value. This is a raw data. Am I right, everybody?
Yes,
Yes,
ma'am.
Yeah. So here, for the single variance in our programming, we are not having any inbuilt function. So we'll to what is the data we have. Okay. What is the data we have? This is the data. Take this. Yes, got it. Data we have taken. And now, after this, 1 minute, let me give some space. Yeah. So now, you just go for the after this. What do you need to do? What is the chi-square formula here? They have given. What is the data has given? Check it. They have given you the sigma square. Population variance is 33,000, right? So write that population variance, POPV, population variance is equal to how much they gave? 33,000. Okay. And what is the sample size? N is equal to what?
10.
10.
10.
10.
This is the data they gave. And did they give the sample variance in the data?
No, ma'am.
No,
No.
ma'am.
Then how can we do? That is, here you need to calculate sample variance. So I'm writing that sample variance. Okay, sample variance is equal to, what is that? Directly you can find the function. There is an inbuilt function, variance, VAR. Okay, VAR of this X. Okay, for all these values only we need to find the sample variance, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So now listen, whenever you are using the function VAR of X, this value will be giving you the calculation of capital S square. That means we'll be giving you the value of 1 by n minus 1 summation xi minus x bar whole square. Okay. So by inbuilt function, we'll get the capital S square. But I want the small s square. How can I find? Tell me. What is the small s square formula? This is the small s square formula. So, but based on the capital S square, I want to find the small s square. How can I do?
N minus 1 by n into capital S.
Very good. This is we have seen in the F distribution how to do the conversion. Did you remember? So this is what is that?
Yes,
Summation
ma'am.
xi minus x bar whole square is nothing but you can write n minus 1 s square. So n minus 1 by n into capital S square. Did you understand how to find the small s square?
Yes, ma'am.
Yes, ma'am.
Yes. So here I'm writing that sample variance is equal to, how can I write then? See, you can do calculation first and later also you can write it. Okay. Here I'm writing that small s. Okay. Small s square. Okay. Small s sample variance. SV I'm taking that. Small s square is nothing but SV I'm taking. Then how can I do that? open the bracket, n minus 1 divided by n. Okay, and for this also you need to give a bracket, otherwise the multiplier will be taken to the denominator into whatever you calculated this variance of x, that is sample variance. Copy this and paste here. Did you understand how to find the small s square value? First, you are finding the capital S square by using the function variance of x, and from that you are converting into the small s square. Is it clear, everybody?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes. And
Yes,
after
ma'am.
this, okay, thank you. And next, after this, you need to find the chi-square calculated value. Then how can I do chi-square? Okay, chi-square cal value underscore cal is equal to, what is the formula? Ns square, right? N into s square means which one we need to take? Here, check
Yes.
it. What do we need
Small
to
s
take?
SV.
SV we need
Sweet.
to take ns square divided by sigma square means which one we need to take? Check the data.
Population variance.
Population
Yeah, here
variance.
I gave a name as POPVAR. Write that, pop variance. Got it, everybody? NS square by
Yes.
sigma square. We got it. And we are doing the comparison with the probability value. Am I right?
Yes, ma'am.
Yes. So how can I find the probability value? That is, you need to check it. That is equal to, and it is always, what is that? In this question, what do you have? What is alternative hypothesis? Is it the two tail or a single tail?
Two tail.
Two
Tail.
tail. So
Two-tailed.
just take that 2 into, open the bracket, 1 minus, okay, open the bracket, 1 minus, if it is a two tailed, p chi square, p chi square, p chi square. That means it will be giving you, it will be converting the table value into the probability value. P chi square means what is that? Giving you the probability value of the chi square calculated value. Okay, and open the bracket. Which one you want to convert? Which one you want to convert? Check it. The chi-square value, whatever you get, that only you need to convert, right? Is it
Yes,
right?
ma'am.
Yes, ma'am.
Yeah. So take this value, whatever the value you get it here, copy it and paste here. Did you understand?
Yes, ma'am.
Yeah, and it is a, what is that? Chi-square distribution is a small sample test, and in this we have a degrees of freedom. So always the probability value will be depending on the degrees of freedom. So what is the degrees of freedom? Here, write that n minus 1, right? Is it right?
Yes, ma'am.
Yes,
Yes, ma'am.
and then we'll get the probability value. And after that, use the if condition. You know this if else condition. I'm just copying this. Is it clear, everybody?
Yes.
Yes, ma'am.
Yeah. Before running, clear everything. Clear everything. Yes. Now run this. Okay, the value stored into the X, population value, yeah, 33,000 stored in pop variance, and N is equal to, you can take 10, or you can write, if you don't know, if you, there are so many values, you cannot count. Then how can you write then? Instead of giving this number, you can write length of X. Check it, what you will be getting? Length of X, and check it N. Got it? N is equal to 10. Is it clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yes,
So
ma'am.
if there are so many values, example I'm telling you, if there are so many values and you cannot able to count, then use the function length of x will be giving you the number of observations in a x. Okay. And then sample variance, it got calculated. And then what is the smallest square? This is calculated, and check it. What is the smallest v? Okay, smallest square. What is the smallest square? It is a 33336. Okay, and then now go for the chi-square cal value. Okay, you got it. What is the chi-square cal value? I want to check it, dear. I want to check it. What is the chi-square cal value? Yeah, chi-square calculated value is how much? 10.10182. Okay, now I'm converting that chi-square value into the probability value. Now check it, what is the probability value? Yes, yeah, you got this. And see, you don't want to type this. So here I don't want to type this, but based on this only I want to see. So select this p value and run. You'll get the probability value. Is it clear? Whichever you want. See, I want to do, I don't want, see here sample variance, I did not write it. I don't know what is the value, but I want to know whatever the value. So what is that? Here, right? Select this and run. What is the sample variance? 37040. Did you understand?
Yes.
Yes. And now
Yes, ma'am.
probability value, I got it. What is the probability value? Oh, sorry. Probability value is how much? It is a 0.6846. So which is greater than probability value. That's what it is showing the result as accept H naught. Is it clear? The p value is
Yes,
more
ma'am.
than level of significance. It is a 0.6 means what? More than level of significance. That's what it is. What is that? It is returning the conclusion as accept H naught. Accept H naught means what is that? There is no association between eye color and the hair color. Oh, sorry. What is the data? What is the data? There is the population test. What is that? Test.
Population variance is 33,000.
Very good. Population variance is 33,000. Is it clear? Everybody?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes. So what is that? This is a way to find the chi-square test for the single variance. And now move to the next question. Okay, previous it is. Now, goodness of fit, dear. Goodness of fit. So goodness of fit means what is that? First, let me explain this. So what is a chi-square test for goodness of fit? We need to check. So the data will be given to you, the raw data. And you don't know that data follows which distribution. Okay, based on the characteristics of the data, you assume the data follows one particular distribution. Okay, based on that, you want to calculate the probability. Okay, but you have some doubt whether what you are assuming the data follows some distribution. It may right or may not be right. You have a doubt. You want to go for the confirmation. Then in that case, we use a goodness of fit. For example, I have a data of X and F, and I'm telling that this data follows a binomial distribution. But I have a doubt. It may or may not follow the binomial distribution. So before going to calculate the probabilities of this data, first I'm checking whether my assumption of this distribution, this follows a binomial, is right or not. I want to check it. Then how to check it, that we will see. Is it clear? Did you understand where we are applying the goodness of fit?
Yes.
Can I get a reply?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah, now here you just check it. This is data. Records taken on the number of birds in 800 families have 4 children are given below. Okay, number of birds 0, 1, 2, 3, 4. And the frequency 32, 178, 290, 236, 64. Okay, this is what is that? Total 800 families. 32 families are having no children. And next 178 families are having 1 children. 290 families are having 2 children, and 236 families are having 3 children, and 64 families are having 4 children. Okay, so there may be a possibility of maybe a children or may not be a children, only 2 possible outcomes. Okay, so for this data, you can apply binomial distribution. This is my assumption. Okay, so here they are asking, test whether the data are consistent with the hypothesis that binomial law holds and the chance of male births is equal to the female births. Here what they are asking, here they want to check it, the data, whether data follows a binomial distribution or not. In which case, here you are telling that the number of children, the number of children means the children can be the male children or the female children, girl or a boy, right? So here you want to check it, Each family is having an equal chance of getting a boy baby and a girl baby. So here you want to find only the two possible outcomes. So that's what here we are using. We are fitting the binomial distribution. Okay. So how to write the null hypothesis? What is the null and alternative? We'll check it. What is the data? What is the procedure? Tell me. What is the H naught? Check the data.
X follows binomial distribution.
Yeah, here they are consonant. Test whether the data are consistent with the hypothesis that binomial law. Okay, this is you want to check. Okay, so the given data follows the binomial distribution. And what is the H1? The given data does not follow the binomial distribution. Okay, and what is alpha? Did they mention anything? No, will be taken as a 5%. And what is the degrees of freedom?
N minus K minus.
K minus M minus.
Very good. N minus K minus M minus 1. N represents number of observations. K represents number of pooled observations. M represents number of parameters estimated. Already this everything I explained while doing the problem. Did you remember?
Yes,
Yes, ma'am.
Yes. And now in this question, here binomial distribution, you are telling that. But binomial distribution parameters are N and P. N represent the last value of the data is the N value. Okay, N value, we know that. So did they give what is the P value? Yeah. Did they give the P value?
No, ma'am.
No. So here you need to calculate the P value. So what can be the M then? N is equal to number of observations. How many observations? 1, 2, 3,
1.
4, 5. 5 observations. Right? Yeah. N is equal to 5 observations. Okay. And M is equal to how many parameters you are estimating?
1.
1.
One parameter. Okay. Okay, done. And after that, what is the K value? Pooling observations, or when you will find, after finding the expected frequency, will come to know whether there is any frequency is less than 5 or not. If it is a less than 5, then we'll move to the polling. Did you remember polling technique?
Yes, ma'am.
Yes, ma'am.
What we are doing in that?
We'll add the observations.
Yes, we'll add the values. Okay, we'll add to the before or next value. Okay, we'll add the frequency. We'll add the value which is less than 5, that into the next frequency value or previous frequency value. Okay, now you just check it, enter the data in our programming, how to see, we'll check it. Okay, first check it, X values. What are the X values they gave? Check it. X values are 0, 1, 2, 3, 4. Okay, 0 separated by comma, 1, 2, 3, 4. And next, what they have given, these are the frequencies. So F is equal to frequencies. Okay, these are the frequency values. Correct? Yeah, frequency values. We got it. And now we need to find the probability value. What is the formula? We need to find the P value. How can we find?
N into P of X, expected frequency.
I'm not asking the function. Let me know generally.
NCX.
No, I want to know probability P value. N value is
X
no.
by N.
Yeah, not X by N, X bar by N. You know that mean is equal to NP in a binomial distribution. So probability is equal to what? Mean by N. Okay. So what is the mean formula? The data is in discrete data. X and F they have given.
Summation of X by summation F.
Summation fi xi by summation fi, right? So do the calculation here. Here, do the calculation first. Calculate the mean value. Mean is equal to, how can you do? Summation of, that means sum. Open the bracket. What do you need to do? F into x. F into x you need to do, and divided by summation of f. Is it clear? Is it clear,
Yes, ma'am.
everybody?
Yes.
Yes. And next one, here n is equal to what will be taken in the binomial distribution to calculate. I'm asking this n value for the binomial distribution to calculate. In the binomial distribution, what can be the n value?
Maximum of
data.
x.
Yeah. So what is the n? N is nothing but what is the last value in the x. That represents the n value. What is the binomial distribution x range? X takes the values. X takes the value 0, 1, 2, so on n. So the last value of x will be the n value. Is it right? Don't say the degrees
Yes,
of
ma'am.
freedom n. Okay. So here n value is what then?
4.
N value is equal to
4.
what? 4. 4 means which is the maximum in the x, or is it right? So directly you can write,
Yes.
or you can use the function maximum of x. That means it will be giving you the this 4. Okay. So you got the mean value and the n value. Then what is the p value? P. N and p are the parameters. Parameter p is equal to what is the formula? Yes
Mean
or
by
no?
n.
By n.
Yeah. Mean divided by n. Okay, so we got it, p value also. Now we need to fit the binomial distribution. Is it right? So first find the probabilities, px, probabilities of x. Okay, px means what is that? P of x, probability. So we need to use a function cx, p power x, q power n minus x. But no need to do all those things. Direct, there is an inbuilt function to find the probabilities. So how can we do that? D binom. D binom. Okay, and open the bracket. Then it is asking D binomial distribution of which values. So for all the x values we need, so write that x comma. Okay, and it is asking what is the size. Size means what is that? N value. For how many observations? N observations. And next you need to give what is the probability of success, that is a p value. Did you understand how to find the probability?
Yes, ma'am.
So
Yes,
probability is
ma'am.
equal to what? Probability of x is equal to what? D binom x comma n comma p. There are the two parameters in the binomial. So write the two. Okay. And next after that, after getting the probabilities, what you are doing? You will find the expected frequency, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So expected frequency, what is the formula?
N into P of X.
Which
Capital
n?
N, P of x.
Capital N. Capital N means what is the meaning of capital N?
Total frequency.
Total frequency, that is sum of f into px, probabilities of x. Okay, so we got the expected frequencies, and observed frequencies are, this is f means observed frequencies, expected frequencies these one. Now go for the chi-square test. CHISQ, chi-square dot test. Okay, chi-square dot test. Open the bracket and give the, what is that? X, first give the observed frequency, that is f, comma, expected frequency, that is EF. Okay, did you understand?
Yes, ma'am.
Yeah, please run this one now. See, first before running, clear the environment window, and this console, if you are clearing or not also, no problem. And now go to run x values. The values are stored into the x, and values are stored into the f, and mean value. Okay, what is the mean? We'll see. Mean. What is the mean value? That is equal to 2.15. And then is equal to maximum of x. That means what n is taking? Check it. Yeah, got it. N as 4. Right?
Yes, ma'am. Yes,
Yes,
Now,
ma'am.
ma'am.
the probability value, p value, parameter p value, what it is? Yeah, 0.538. Now, what are the probabilities of these all binomial distribution probabilities? Okay, I want to see what are the probabilities. Yeah, these are the probabilities of the binomial distribution for all x. X is equal 0, this is a probability. X is equal 1, this is a probability. X is equal 2, this is a probability. X is equal 3, this is a probability. X is equal 4, this is a probability. Okay, now find the expected frequency. Okay, what are the expected frequencies? You got it? Yeah, these are the expected frequencies. Now, just find the chi-square test for the frequency, observed frequency and expected frequency. Then run. Why it is wrong? Check it in chi-square dot test. Check it. EF, chi-square approximately may be incorrect. Okay, this is a warning message. Don't worry about the warning message. Until unless if you get an error, then we don't worry about the warning message. Yeah, so what is that here? Data, F and expected frequencies, they have given observed and expected frequency. So this is a chi-square cal value. And this is a degrees of freedom. And this is a probability value. Is it clear? So what is the
Yes,
probability
ma'am.
value? Probability value is this is, copy this and just go for the comparison. Go for the if condition. Go for the if condition. Yeah. Now check it. Yeah. P value. Okay, I did not run this. P value is what? It is more than 0.05. That's what it is returning as a accept H naught. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Now suppose if I have given you for this data, I asked you to fit a Poisson distribution. How can you do this, dear? In Poisson distribution, what is the parameter?
Lambda.
No.
Lambda.
Okay. So I'm just copying the same thing. In your syllabus, you have binomial and Poisson only. Let me take another one. For the same data, I'm using for Poisson distribution. Okay. These are the x values and f values. So if the parameter lambda has not given, how can we estimate?
Mean.
Mean. So mean represents this lambda. Okay, fine. Then this N and P is required? No.
No.
Yeah. Then here in place of binom, what do you need to take? D binom. In place of this, last year we learned that.
Poise.
Depoise.
Yes, yeah, D poise. And in the Poisson distribution, what is the parameter? N and P will not take. What is the parameter?
Lam.
Mean.
Lambda.
Lambda. Here lambda is nothing but what we are taking, mean only, right?
Mean.
Is it right?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yes.
Now run it. Yeah, run it. Okay. Yeah. So what are the expected frequencies we got it? These are the expected frequencies. Now go for the chi-square test. Yeah, P value is the same thing we got it. Because why it is the same value you got it? Because see, if listen, if the number of trials are more, then binomial distribution tends to Poisson distribution. Did you remember?
Yes, ma'am.
Here we have taken
Yes,
what is
ma'am.
that? Here we have taken 800 trials, 800 families. It is a big number. So that's what the binomial value will be equal to the Poisson value. Is it clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Any doubt in this?
No doubts, ma'am.
Yeah, with this we finish. Acceptation not means what is that? The data follows a binomial distribution. For the previous problem I'm telling you. Is it clear?
Yes, ma'am.
Ma'am.
Yes,
Any,
ma'am.
any doubt anywhere?
No,
No,
ma'am.
ma'am. No,
With
ma'am.
this,
Ma'am, in Excel, how we can call the data you told, you'll tell that one. From
yes,
Excel.
yes. 1 minute. Okay, 1 minute. See the data. This is the data I have. Okay, thank you, dear. Nice, very good. You remember. I'm taking this data into the Excel, dear. Which class do you have in the next time?
CS.
Yes, ma'am.
Hmm, okay. I'll explain you how to read the data. Yeah. Hmm. I copied that one, you know. Okay, let it be. Read that. Number of birds. Here, number of birds is nothing but x values. I'm taking that. Here, what is that? 0, 1, 2, 3, 4. Okay. And next, go to the frequencies. Here, what is that? 32, 178. Something I'm taking here. Don't worry if I'm entering wrong numbers also. Ayyo. 32, 178, 290, 236, and 64. This is the data I have. Okay. Now I'm storing this. I'm just saving on a desktop. BD, binomial distribution. See. Okay, I have stored this on desktop. Okay. Now, here, first you just write that get WD. That means where we are at present. That means the path which it is considering this R programming file. Okay, so check it. It is using C uses documents. It is taking a documents. Okay, our program is, what is that? The setup path for the program is documents. But our data is there in a download on the desktop, right? So you need to set the directory. So write that set WD. Open the bracket. Okay, and next after this you just check it, take the data. Okay, now you want to set it, you want to set the directory. Okay, you want to set the path. So I'm taking the data here. I'm taking the data as binomial distribution data. I'm taking a table, something I'm taking. So table is equal to C, open the bracket. Yeah, where is the desktop? Okay, let me take this. Where is that? Here it is. So copy this, go for the properties. See, click on the right click, go to the properties and select the path. Okay, go to R and then paste it. Okay, and after that, take a slash and here, what is the file name? BD. Copy it and then paste it, file name, and it is in the form of Excel. What is that? Excel file. Write that Excel SX extension of the file. Okay, and here you just, whenever you are taking, you need to change the forward slash to the backward slash. Okay, sorry, it is a backward slash to the forward slash. Backward slash to the forward slash. No, I forgot. Open the quotations. We'll see, will it work? Yes. Now here what is that? The table, the data, this binomial distribution data is stored into the table. Now run this table. Okay, the table, what do you have? The directory is stored into this one. Is it clear? Is it clear?
Yes.
How to set this? And from the table you can use this one, variables. Tomorrow we'll do one problem based on this table and I'll let you know how to read the variables in the R programming from the table. Okay, from outside of the R programming. Okay, that I'll explain tomorrow, dear, because it takes minimum 5 minutes. So I have another class, dear. Okay, any doubt anywhere? Is it clear? Till now is
No.
clear, everybody?
Yes, ma'am.
Yes.
Yes. And now you can see the what is the path of the directory also. Okay. Now you just check it, get WD. Yeah. Documents. Okay, tomorrow I'll explain here. Tomorrow I'll explain this. Okay, how to read the data from the outside of the source, that I'll tell you tomorrow. Okay,
Yes.
read.xlr. I'm using Python, no? So XLSX. CSV. Okay, here we need to read something. I'll tell you tomorrow. I'll tell you, dear. This is okay.
Ma'am, read Excel file import చేసుకోవాలా ma'am?
లైబ్రరీ ఇంపోర్ట్ చేయాలి, రైట్. లైబ్రరీ ఇంపోర్ట్ చేయాలి, రీడ్ ఎక్సెల్. సిఎస్వికి అయితే డైరెక్ట్ ఉంటుంది, రీడ్ ఎక్సెల్, రైట్.
In Python we do read Excel, no, ma'am.
Yeah, in Python also we need to call the Excel file that we are reading that. Here also you need to read that library. We need to call. Packages. XLSX. Yeah, it is installing. By default, it will be there. CSV files we can read directly here without calling any library. But suppose if you want to use Excel, you need to take this one XLS. And see, in Python also for CSV, we are no need to install any library. Did you remember in Python, I told you that. Go for the Excel, read the Excel file. Did you remember?
Yes, ma'am.
Same like in this one also. This I'll tell you
Okay,
yes,
ma'am.
what's happening. I forgot it. I'm using Python nowadays, so I forgot this, how to read the data from Excel.
The important
Library of
pandas lo
read
main
Excel.
That is, I'll tell you, dear. Without knowing, I cannot tell you. Firstly, I have to check. Okay. Don't club that Python here, dear. This is a little different, and that is little variation only is there. Not much, little variation. Okay.
Yes,
Yeah.
ma'am.
Tomorrow I'll tell you that. And so with this, we finished our entire syllabus. All complete syllabus we finished, dear. Okay, complete syllabus we finished 100% Excel theory and R programming. I left with only the sending the material. That is, I'll share with you in another 2 days. The material, is it clear?
Yes, ma'am.
Yes.
Can anybody please send me this